Hello, my name is Ruben Chavez, and I am a graduate student at the University of Illinois at Urbana-Champaign, and I will be the narrator of this video series. This work was supported by the IFAN's Food Microbiology Committee. As discussed in the introduction video, the simulation app gives the user a tool to recreate a desired sampling plan and obtain the probability of detection of a hazard, either pathogens or mycotoxins, as well as the probability of acceptance of the produce field or grain lot. This gives the opportunity for the user to compare different sampling plans and different scenarios of contamination to analyze the best possible scenario for hazard detection and acceptance of the tested field or corn lot. This video will explain the required inputs for the sampling simulation of a grain container. These inputs allow the user to simulate and compare results of different sampling scenarios that could affect different mycotoxin levels, different homogeneity of corn after sampling, or different number of sampling probes. In addition, the user can simulate the contamination distribution and evaluate how this affects mycotoxin detection and acceptance probability of the sampling plan. For corn simulation, the app requires 15 inputs. For each input, the modeling app will have a specific question that asks the user to fill or choose the required option according to the intended sampling plan. Some inputs have predetermined values that have been selected according to literature studies, but can be customizable according to the user preference. The first input is the dimensions of a grain container in meters. The app can simulate three types of grain containers: trucks, barges, and hopper cars. The user can customize the length, width, and depth of their grain container to accommodate the sampling needs depending on their own farm's reality or preferred management practices. The next inputs are the single kernel mass of a corn and the kernel density. The single kernel mass refers to the mass in grams of a single kernel according to the corn strain, while the kernel density is the density of a single kernel of corn in grams per centimeters cubed. These values can vary depending on the strain of corn used. The app has a recommended value of 0.3 grams for the kernel mass and 1.28 grams per centimeters cubed for the density. The user can customize these values according to the intended plan. In addition, the user can select the type of mycotoxin under study and the regulatory thresholds according to the government regulation and the final purpose of the corn. The estimated level of mycotoxin level in the container is an estimate level of the overall mycotoxin contamination present in the grain bin. The user can use previous contamination records to have an estimate level for the desired batch of corn that will be analyzed during sampling plans. The expected distribution of contamination refers to the mycotoxin distribution in the contaminated grains. The user has two options: uniform distribution and gamma distribution. The uniform distribution refers to the equal levels of contamination present in the grain bin, while the gamma distribution is used when contamination has a right skewed probability of distribution. A skewed distribution is a more representative of a real-life scenario. However, if the grain bin has been thoroughly mixed, a uniform contamination can be used. The next three inputs refer to the mycotoxin characteristics of the contaminated grain. The mycotoxin level in contaminated grains is the estimated overall mycotoxin level at single kernel level. The app has a recommended value of 4,000 parts per billion. Then, the lower bound of the mycotoxin levels is the minimum contamination expected in the corn. The app has a recommended value of 20 parts per billion. The following input is the number of kernels in the contaminated cluster. For this, the app suggests a value of 10. For a grain container that has been poorly stored, it is recommended to have a higher number of contaminated kernels, and for all the three inputs, the user can customize the values according to the intended sampling scenario. The estimated shape of contamination is the spatial shape of the cluster where the contaminated kernels are present. In this input, the user can estimate the length, width, and depth in meters of the contaminated clusters. The app offers a recommended value of 0.004. The user can adjust the values according to the estimated number of contaminated kernels and the intended sampling scenario. The next input is the diameter of the testing probe. Here, the user can select the diameter of the probe used for sampling according to the grain container that is tested. The recommended value is 0.04 meters, but the user can customize the value according to the probe used in the intended sampling plan. The sampling strategy refers to the sampling approach that will be utilized to collect the samples. The app has three options. The first one is simple random sampling, where the probe inserts will be at random and all selections of the bin are equally likely to be selected. The second one is stratified random sampling. In this sampling strategy, the grain container will be stratified into non-overlapping subgroups according to the contamination distribution, and probe inserts will be random in each subgroup. And the third one is the GIPSA systematic sampling. In this sampling strategy, samples are taken at regularly spaced intervals over a space. The initial location is chosen at random and the consequent locations are defined so that all locations are at regular intervals. In the industry, the third option, systematic sampling based on the GIPSA manual, is used according to regulatory standards. Finally, the two remaining inputs are the homogeneity of corn after sampling and the detection method. The homogeneity of corn after sampling is a value that describes how fine the powder is after grinding. The value of 0 refers to no grinding, while 1 equals a fully grinded corn container. In the app, the detection method for mycotoxin measurements is ELISA. The following video for contamination sampling simulation will show how to use the simulation app and analyze the results for sampling analysis according to a real-life scenario.